Hi everyone, this is a video regarding the solutions of exercise 2.1, that is the chapter on similarity of triangles. Now, first question goes like this: fill in the blanks with the correct choice from the brackets. There are two choices given in the brackets, you have to choose one of them. The first sub question goes like this: all circles are dash, congruent or similar. Of course, we discussed all circles are similar because they are of the same shape, but only those are congruent which have the same radii. Here they have not mentioned about the radii, that means all of the circles must be similar. Second sub question: all squares are dash, similar or congruent. See, for the squares to be congruent, their edges must be equal. Here we are not talking about anything about the edges being equal. They have just said squares. Basically, all squares must be similar. So the answer is similar. Okay. Third sub question: all dash triangles are similar. Options: isosceles or equilateral. Obviously, isosceles triangles may be of different shapes. One example, let me show you. This is an isosceles triangle. Probably I am going to write this as 20 degree. So out of 180 degree, if this one is 20 degree, the remaining two angles is together 160. Since they both are equal, they must be 80 and 80 degree. So now you have an isosceles triangle with two angles equal here. I'll draw one more isosceles triangle. In this example, you find one more isosceles triangle with their angles 160 and 10 and 10. Here again we have an isosceles triangle with two angles equal, 10 degree and 10 degree. But they both are not similar. Clearly they are of different shapes. So we cannot say that isosceles triangles are always similar. Neither we can say that they are congruent. But what about equilateral triangles? If you consider any equilateral triangle, all the three angles of an equilateral triangle are same, that is 60 degree each, because of which their sides will be proportional. Example, if one triangle has the sides 5, 5, 5 and another triangle has the sides 2, 2, 2. Now, if I divide the corresponding sides 5 by 2, 5 by 2, 5 by 2, then my representative fraction will be 5 upon 2, or the scale factor is 5 by 2. That means they are similar. So, the equilateral triangles are always similar. So let me write the answer: equilateral triangles are similar. Fourth sub question says that two polygons of same number of sides are similar under conditions A and B. Two conditions. Corresponding angles are dash and their corresponding sides are dash. See, the corresponding angles must be equal and the corresponding sides need not be equal, but they need to be proportional because the scale factor has to be same. So we can say that the first blank can be filled with equal, which we are talking about the angles. And when we come to the sides, they must be proportional. Let me just discuss this once more. What do you mean by proportional? See, proportional means the ratio of the corresponding sides, ratio of the sides. Let me again take one example of a pentagon here. Two pentagons I am taking. Okay, I'll call this A, B, C, D, E. I'm calling this P, Q, R, S, T. Okay, if I am just considering that AE is corresponding to PT and AB to PQ, in that case, I can write AE upon PT is equal to, see, this is a ratio of two corresponding sides. I should take one more ratio, only then I can talk about proportion. So one more ratio is AB upon PQ, which should be again equal to BC on QR BC upon QR, which should be equal to DC on SR, DC upon SR, which should be equal to ED upon TS, ED upon TS, and all of them should be equal to some constant which will be called as the scale factor. So that means they are not equal, the corresponding sides are proportional. So the answer is proportional. Second main question says that, first sub question, give two examples for similar figures, and sub question 2 says that give two examples for non-similar figures. Okay, let's discuss. So talking about the first sub question, talking about some example of similar figures. I am taking two quadrilaterals here, 4 sides each, right? The first one is called ABCD, the second one is called PQRS. Let us look at the angles. By the symbols you can make out that angle A is equal to angle P, angle B is equal to angle Q, angle D is equal to angle S, angle C is equal to angle R. Now, with these angles being equal, we have got one part right, that is the corresponding angle should be equal. But is that enough? No, we are talking about the sides. Let us take some sides. I am going to take this as 2, just for the example it is. This is 4, this is probably about 5, this is about 3. And here I go for 8, 16, 20 and 12 in this case. Now, how to check the scale factor? Let's take the corresponding sides. First, as I as I told you before, we take all the numerators of the proportion from one diagram and all the denominators from another diagram. So here I am going to take all the numerators from ABCD, that is AB and BC, CD and AD. Now for the corresponding sides, for AB is connecting the single line angle and the double line angle. Here I have single line angle and the double line, that is PQ. Then for BC it is QR. For CD it is RS. And for AD it is PS. These are the corresponding sides. The ratios must be equal to the scale factor, only then they are similar. So they all must be equal. You can check AB by PQ, 2 upon 8. 2 upon 8. Simplify that. 1 upon 4. BC is 4 by QR, which is 16. 4 ones are 4 fours are again 1 upon 4. What about CD by RS? CD is 5, RS is 20. So 5 upon 20. 5 ones are 5 fours are. Again it is 1 upon 4. And last but not the least, AD, which is 3 divided by PS, which is 12. 3 ones are 3 fours are. So 1 upon 4 is the scale factor. There is a common ratio for all of them. That means the sides are in proportion, means these two sides are similar. Second sub question is, they are discussing about give an example for non-similar figures. I am taking here two triangles here. Triangle, obviously we feel that both are three-sided figures, they must be similar. Not so. Let us see why. Here all the three sides are 5 centimeters. I am taking 5 units. So let me name them AB, BC and AC. So if we try to divide it by corresponding sides, none of the sides are corresponding because here all the angles are equal to 60 degree. Here all the three angles are different. None of the angles are marked same here. See, here single lines are there. Here double line, triple line and a shaded angle. None of them are equal. And even though we try to divide any of the sides, what happens? Let us see. If I take anyone like XY, YZ, XZ. One combination I am trying here. So AB being 5, AB is 5, 5 upon 2, this is 5 upon 2. BC by YZ, BC being 5 and YZ being 4, 5 upon 4. And next AC being 5 and XZ being 5, 5 upon 5 becomes 1. These two cannot be simplified, means they are not equal. 5 upon 2 is not equal to 5 upon 4, which is not equal to 1. That's for there does not exist a scale factor. A constant is not there. In that case, this given two diagrams or figures are not similar. Number 3 says that state whether the following quadrilaterals are similar or not. There are two diagrams given. One, a PQRS, which has 4 sides equal, but nothing is mentioned about the angles. So we cannot just assume that all the angles are equal. By the looks of it, they look as if it is a rhombus, because you see two acute angles and you see two obtuse angles. Almost. They have not given them equal, so we cannot just assume they are so. I am just telling you the possibilities. But on the other hand, we have ABCD, which looks to be a square because all sides are equal and all corner angles are 90 degree. So here, since we are not sure that they are 90 degree, we are not supposed to follow by the shape. We are supposed to follow by what is given in the symbols. And they have not given anything about the symbols. Regarding the symbols, we don't know. So, with the known data, this is not sufficient enough to say anything about their angles. So, all we know is the corresponding sides, that is, suppose I take PQ, QR, RS and SP. So, if I divide with the sides of the second diagram, that is PQ by AB and QR by BC, RS by CD, SP by DA or AD. If we substitute the values, let us see what happens. PQ by AB is 1.5 by 3, which is 1 2 it's 1 by 2. QR by BC similarly is 1.5 by 3, that is also 1 upon 2. RS also is 1.5 and CD is 3, so again 1 upon 2. SP being 1.5 centimeters and DA being 3 centimeters, again it is 1.5 by 3, which is 1 upon 2. So all of them are equal, means there is a scale factor or the representative fraction which is 1 by 2, but is this enough? The sides are proportional. Is it enough to say the two quadrilaterals are similar? No, because we need to go for the angles. The corresponding angles, however, are not equal. So one of the conditions satisfied, but the other condition doesn't. So these two quadrilaterals are not similar.